All right, welcome. I'm going to talk a little bit about some R code and solving some problems that relate to a homework set for regression. And so I'm going to go to R and look at some of that. So let me just switch over here to R. And so I want to just work through some problems. I'm going to make a few mistakes in here intentionally just to help you see maybe how to work around some troubleshooting or some situations where you might have a problem or an issue. So to start off here, I'm just going to set the working directory, and I'm going to do it as, I'm going to make a mistake here. I'll just say ECN410. I'm going to run this, and it says error, unrecognized, escape in character, blah, blah, blah. So if you have a problem getting started, just go back and look, make sure that this path actually exists. Certainly if you've got a Mac, it's going to look a little different. So if you're a Mac user, certainly be aware, but I just needed to have the / instead of the \, and there it works. And the next thing I want to do is read in a data set. I'm going to read in this data set up here. I've already reminded myself of the name there, and I'm going to just call it H1. And it's a CSV file. So I'm going to say read.csv, and I'm going to say file equals, and I'm going to make a mistake here intentionally. I just type in E1 SU22 Toyota. This has prices of Toyotas in there. And I'm just going to click run. And it says it's got a problem. What's the problem? Well, there are a few problems in here. One is that I need this to say .csv. I have to name it correctly, or thoroughly. And I need it in quotation marks. So if things aren't reading in correctly right off, just look things over. Is everything spelled correctly? Things that are capitalized versus lowercase, that's important. Do you have the proper extension? Do you have quotation marks where you need them? Maybe you didn't have an equal sign, right? It's just a matter of looking things over, and that can take some time to just check. But there is a troubleshooting page in Canvas that you can look over just to help you get settled with some things. So again, it might take a few tries and some frustration, but if you just double check everything, just so that's a good way of troubleshooting, right? How do I have everything typed in correctly? Because if you don't, that's going to cause a problem. So it shows up there. Now I'm going to do something here. I just want to take a quick peek at my data. So I'll just say head H1, the data set name, the data frame name, and it tells me I've got a few things: price, miles, mod year, years. So this is a data set, has some, you can imagine some Toyota automobile car prices, how many miles and thousands of miles, the model year, how many years that is. So I just want to use the first 30 observations. So I'm going to create a subset here. And the way that I do that is I take H1 and I'm going to create a new H1, right? So H1 is going to equal a subset of H1. And what I'm going to do here is I'm going to say rows 1 through 30, and then comma, the next entry I'm going to leave blank, which tells R to make it have all of the columns. So I'm just going to run that. And then for some purposes a little later in this, I want to add a variable here. So I'm going to do something. I'm going to say H1, I want to create a new variable called ln miles. That's the log of miles. And what am I going to do there? log, which is natural log in R, of H1 miles. So I'm just creating a new variable. It's going to be added onto the data set and do that. And so now, in fact, if I take this head, they'll see a new variable added on there. There'll be an ln miles as well. So let's just do that. And you can see that down here, hopefully, right? ln miles. Okay. So how many observations are there? Well, I hope there are 30 now that I had back on line 8, told it to make there 30, but I'm going to type in n row h1. It'll tell me how many observations there are. So click run. And down here below it says there are 30. So that seems to work correctly. Maybe I want to get the mean and the variance. So mean, just do mean, and h1 for, I pick a variable, we'll just say price, and it tells me what the average is. I can also do a 5-number summary. So if I type summary h1 price, give me a 5-number summary for that. And you'll see the mean is also here again, $25,137. So we got rounded, but that's where that is. If I want the variance, I can do variance h1 price, and it'll show up down there. Or maybe I wanted the standard deviation instead. So standard deviation h1 price. And I can then do some little check here, right? I can take this number, the standard deviation, and I can square it. So just like that, and see if it matches the variance. And it does. I mean, they're very close, right? 33, 6, 7, 2, and one says 30, and the other says 29. So there's some rounding that happened in there somewhere to get that a little bit off, but hopefully it looks like they're the same. All right, so then I can make some plots. Maybe I want a histogram, and we'll say H1. Again, we'll do this for the price. And I can get a histogram over here. And then how do I interpret that? This one looks left skewed. So if I'm looking at the histogram over here, looks left skewed. You could have all different kinds of appearances there. Things could be bell-shaped, they could be uniform, they could be bimodal, lots of different possibilities. But got that there. You can also over here do things like getting a box plot, create different graphs, and that's just a matter of practicing with some different things in R. All right, so then I want to get a model. It says I'm going to run a regression. So what I want to do. So in this case, I'll just say M for my model. Let's suppose I'm going to make a mistake here. Intentionally, right? Let's just do this. Price, and I want to regress it on what were my variables again? I'm going to go back and check. They were miles, and years, and the log of miles, and my data set is H1. Now, I don't think this is going to run, but let's just see. Yeah, it says something's wrong, error in there. But I can read the error message and say it says could not find function LM. Maybe though you're thinking, oh, I think that's been in some of the lecture videos. It should be lowercase LM. So there are all kinds of mistakes that are possible here. Right? You use the wrong variable name. Maybe you called this price when it should be price with all caps. Maybe you forget the tilde in here. Maybe you forget a plus sign. Maybe you forget a comma. All kinds of different things. If it doesn't run, look at the error message down here. See if you can figure it out and just work on troubleshooting to get the right line in there. It's just a matter of practice and paying attention to some details. All right, so it ran, but it doesn't show any output. So that's not helpful if we want to see output. So we need to type in summary M for the model, or whatever I called it, in this case M. And then I run this. Okay, so it says, what's the R square? and I can find multiple R squared is right there. So 0.1649 would be the answer in that example for what that is. It says, what's the estimated change in Y from a change in an explanatory variable? So let's just pick miles right here. So negative 60.79. So as miles increases by 1, and this happens to be in thousands of miles, I happen to know what these data are. This is from a Toyota dealership here in Phoenix. Car prices, but so as miles increases by 1, goes up by 1,000 miles, the estimated price of the car, or on average the price of the car, goes down because the coefficient is negative, right? So if I'm looking here at miles, it's negative 60.74, so it goes down by $60.74 if miles goes up by 1,000 miles. Okay. What are the p-values? Well, the p-values are in the last column again here, and I use those for hypothesis testing. So notice that this one here is less than or equal to 0.05. So that means for years, I would reject the null hypothesis that the coefficient is 0 at the 0.05 level or better. In this case, it's exactly 0.05, so it's just right on. But for miles and log of miles, this is greater than 0.05. Oops. So that implies I fail to reject. And for this case, I reject. Right. Okay. So that's just reading the p-values and deciding whether or not to reject. No different really here from things we'd have done in an introductory statistics course. Now let's test the hypothesis that a slope is something other than 0. So we want to consider maybe that that years results in $1,000 decrease. So let's just go with this. Let's have the hypothesis be that the coefficient on years is negative 1,000. So at a high level, or just typing these values in, I could say negative 805.19 minus 1,000. So minus a negative is, or so minus a negative 1,000 is the same as, I think, as plus 1,000. So what do I have here? I've got the point estimate, the negative 805.19, minus the hypothesized value, the negative 1,000. So minus a negative is positive. And then I divide that by the standard error. So the standard error for years is 391.67. And then this is going to give me the t-statistic. So it's not very large, 0.49738. And you can be more precise. There are some little coding pieces. Again, you might go back to look at some video, or actually, let me just give one in here. You can get more precise values than negative 805.19. And so if you want to get a more accurate thing here, you could do something like this. So say summary M, and then say coefficient. And then if I want that coefficient on years, it's in the third row, right? So the first row says intercept, the second row says miles, the third is years, and it's in the first column. The column is estimate. So it's the third row, the first column. And you can see it was a little more precise, right? It says 0.1923 instead of 0.19, right? So it gives you a more precise value. All right, so then how do you interpret this? Well, in this case, 0.497, you can go back, look at a t-table or pull that up in R. That's going to lead to us failing to reject. So I failed to reject the hypothesis that the coefficient on years is negative 1,000. right? I don't have evidence to suggest that it's something other than a $1,000 decrease in the price per year older that the car gets. Okay. Find the standard deviation of the residual. Okay, so the standard deviation of the residual is right here, 1771. There's something else I could do, right? I'm going to just type in down here below, SD for standard deviation. And then you haven't seen this yet in lecture video, I'm sure, but I'm going to just tell you that resid gives you the residual. So I'm just resid for M. And yeah. And it comes out a bit different. That has to do with, yeah, it comes out a little bit different, but you can see, well, maybe they look too different because the way in which this is calculated is slightly different in terms of how many, the denominator for how this is going. But hopefully they don't look, well, they probably look a bit different. They do look a bit different, but they're just different ways of calculating what that is. The standard deviation of the residual, though, at this stage, probably just look at this residual standard error, right, is what we're thinking about. Okay. So what's the variance of the residual? So the variance of the residual is then this value squared. It's something called the mean square error. So you just take the 1771 and square it and get that out. The 3,136,441. It's the variance of the residual. Okay. Partial F-test. So want to conduct a partial F-test here. So let's just look at this then. Let's go and type this in here. So let's just suppose we're going to do, let me install a library. So let's say I've got library AR, and let's just do that. Because I think this next thing I want to use, linear hypothesis. Okay. So I just typed something in wrong there, maybe. Linear hypothesis. I don't know what's going on there. For the model, so M, and then I'm going to tell it what the hypothesis is or hypotheses are. And they are that, let's say, miles equals 0. And I had another variable called log miles equals 0. So this is for doing a partial F-test. I've got a null hypothesis that the coefficient on miles is 0, and at the same time on log miles is 0. So we have that in there. So I just go run, and it produces this output here. It repeats what the hypothesis is, so you can see that. And so you've got this restricted model here that has these two coefficients as being 0, and it shows you down here an F statistic and a p-value. So highlight those items here, an F statistic and a p-value. So this p-value is fairly large at 0.5151. So if our value for alpha, our significance level, is 0.05, we're going to fail to reject based on that p-value that you see there. So we, maybe you are okay with the notion of accepting the hypothesis that those two coefficients are 0, right? So they're yeah, we don't have strong evidence that they're something other than 0. Let's get a confidence interval. So confidence interval for the coefficient. Let's do that for any one of these variables, but let's just say CONFI. Something's going a little wonky with my thing. Confident, this model M, and let's just have the variable be, in this case, miles. And then maybe we want to do level, let's just say 0.8, so an 80% confidence interval, just to choose a silly number. That's not one you would likely want to go with, but let's just give it a try here. And so it comes out and gives me the confidence interval, right, anywhere from negative 137.7691 up to 16.29, right? That interval includes 0, which means, again, we would fail to reject the hypothesis that it's 0. So just get that idea out there. All right, so then let's suppose we want a predicted value, and then how we would interpret the predicted value. So let's go ahead and create a new observation here. So let me just call this new obs, and I'm going to create a data frame here. So I'm just going to say data.frame, and I need to have the values of the explanatory variables. So those were the miles, log miles, and years. I'm going to be a little loose with this here, because I'm going to say miles is something like 30,000. So I think that was just 30. Years is going to be, let's just say it's 3 years old. And then log years, or log miles, I would need to find out what is actually the log of 30, which I guess, let's go ahead and just do that. Log of 30, 3.4. So then here for log miles, let's just do that as 3.4. Just do that. Okay. And then I want to get a prediction interval. So I'm going to go ahead and put in predict, and I'm going to have the model M and new data. And I have a typo in there. Let's just leave it in there, so it'll give you an error message. New obs, and then let's go ahead and go with interval equals prediction, and let's specify again level. Let's just make it 0.8, which is unusual, but let's do that. And I'm expecting to get an error message here that I'll then have to go and fix. And it ran for me anyway, which is strange. Why did it run? Well, I thought it was going to give me an error message, because it should have been new data. No, that was goofy. Looks like it didn't really care too much. But I had mistyped that to begin with, and so I was expecting it to give me an error message. But anyway, all right. So it tells me what the fitted value is. So basically, if I were using the equation up above, go back far enough, using this equation here, and plugging in my values of 30, 3, and 3.4, what would be the result of that equation? Well, the result would be a $25,889 car, basically, and 57 cents. And then the lower value is there's an interval around there, right? So for the prediction, the lower value would be $23,443, and the upper value $28,335, right? So if we're trying to predict the value of this car, or the price of this car that's got 30,000 miles, it's 3 years old, and the log then of 30,000 miles, 3.4, which I just added in there for just to be silly a little bit, do a partial F test, that our prediction interval, 80% prediction interval. 80% of the time, we'd expect that car to be worth between $23,443 and $28,335. Okay, so hopefully this serves as a help in terms of just working through some of the homework and getting going with that. And so good luck, and post any questions that you have to let me know. But hopefully this is a good help to work with this.